Okie dokie. Adding fractions. We all know that we can add fractions only if they have a common denominator. Well, that denominator doesn't have to necessarily be a quote-unquote number. It could also be a variable. For example, these two fractions both have an a for a denominator, and I can add them together. I add them together, and they simply become 4 plus 9 over a. 4 plus 9 is 13 over a. Down here, I've got 6 over a, and I have 9 over 3a. Not a common denominator, but I can make it a common denominator if I can have a 3 over here. So what I'm going to do is I'm going to multiply this fraction by 3 over 3. So I'm just sort of scaling it up, and I'm going to end up with 18 over 3a plus 9 over 3a, and now I can add them together because they have a common denominator. And that's 27 over 3a. Let's see. Down here, okay, these two fractions, no common denominator, so I'm going to have to do something about that. Well, here's a little trick. If I have two denominators that are both different variables, I'm just going to multiply each fraction by the other variable over itself. So I'll show you what I mean here. The one that has the n in the denominator, we're going to multiply that by m over m. And the one that has the m in the denominator, we're going to multiply that by n over n. And remember, m over m, n over n, those are just other ways of writing 1, and you can multiply anything by 1 as many times as you want. You don't change the value. So we're not changing any values here. We're just changing what the fractions look like. In a sense, we're unreducing them. All right, so let's say, look here, that would give us 2n, and in the bottom, m times n. And over here, we have 5m, and we have m times n. So now they have a common denominator. We can add them together, and we get 2n plus 5m over mn, which is m times n. Okay, one last one. I have 2 plus 6 over m. Okay. Well, I could think of this as like a 2 over 1. So 1m, don't have a common denominator. We're going to have to do something about that. So I'll take this fraction, and I'll multiply it by m over m to get 2m over m. So I've kind of, in a sense, unreduced that fraction. I'm scaling it up. And then plus 6 over m. So now I have a common denominator, and this becomes 2m plus 6 over m. And also keep in mind, and we've done this before in a couple other problems, but a process like this, you can always split the fraction apart into something like this, and then take away, cancel the two m's out, and come back to where you started. So this whole process can be reversed as well. So again, for adding fractions together, they do need to have a common denominator, but that common denominator could be a variable, an unknown. So I can add two fractions if their common denominator is both the same, if it's like an a. If it's something close to being the same, like a and 3a, I can take one of the fractions and kind of scale it up by multiplying by whatever I'm missing. Right? So I was missing a 3 over here, so I multiplied by 3 over 3 to get that 3 back. If I have two completely different denominators, then I can multiply by whatever I'm missing in each denominator. I multiply both numerator and denominator. So for example here, the n, I was missing an m, so I multiplied by m over m. And this m is missing an n, so I multiply by n over n. This procedure right here, you want to kind of just pay attention to that, because there's plenty of opportunities to use that little trick. Okay. All right. Adding fractions with variables in the denominator.